Imagine walking into a car dealership. You see the most advanced, just mind-bending prototype vehicle on the floor.
Oh, yeah.
You walk up to the dealer and you put down a $10 billion completely non-refundable deposit.
Right, just pocket change.
Exactly. And you're doing this just to test drive that car for a few months, purely to see if you, maybe want to buy it later for $60 billion.
Which is an insane premise.
It sounds like absolute financial madness, but that is exactly what SpaceX is doing right now by putting down a $10 billion deposit to test drive an AI coding startup called Cursor. Welcome to the deep dive, by the way. Today we're looking at some really fresh tech industry analyses, some academic research papers on AI productivity, and these crazy recent financial filings from SpaceX.
Yeah, and it's the kind of move that completely breaks standard valuation models. I mean, we're looking at sums of money that literally rival the gross domestic product of small nations. And it's being deployed not as an outright acquisition, but essentially as an exploratory down payment. The stakes here, they go far beyond just software.
Yeah, because if you look at the recent Wall Street analyses coming out of SpaceX this April 2026, the end game isn't just acquiring a cool new tool for programmers. It's this highly calculated leap toward dominating the entire future of knowledge work.
Absolutely.
But, before we get to world domination, our mission today is to figure out if this deal is genius or madness. So we need to look at the mechanics first, because this is not how tech acquisitions usually work. Nobody just drops $10 billion on a maybe.
No, they don't, which is why regulators and competitors are kind of scrambling right now to understand the structure here. What SpaceX executed is a highly aggressive call option.
A call option.
Yeah, they aren't handing over $60 billion today. Instead, they are initiating this integration phase.
Okay, so what does that look like in practice?
Well, they're embedding Cursor software deep into SpaceX's internal ecosystem, right? Running it on SpaceX's massive supercomputers and basically measuring the output.
So they are basically renting the company to see if it actually scales up under pressure.
Exactly.
And what if it fails the stress test? Like if Cursor turns out to be overhyped and doesn't actually revolutionize their workflow?
Then they walk away. The partnership dissolves. But, and this is the kicker, that walkaway comes with a $10 billion breakup fee.
Wow.
Payable to Cursor for the joint work conducted during the trial. So SpaceX's floor here, their absolute minimum risk is a $10 billion loss just for running an experiment.
There has to be a strategic reason for structuring it with such a massive penalty, right? Like, if SpaceX really wanted this tech, why not just offer $50 billion right now and buy them outright? Why play this complicated options game?
It really comes down to market timing and, well, freezing out the competition. You see, Cursor was actually days away from closing a $2 billion funding round.
Oh, I didn't realize it was that close.
Oh, yeah. And that round would have valued the startup at around $50 billion. So SpaceX swooped in with this option structure to preempt that specific round. By offering a guaranteed $10 billion floor and a $60 billion ceiling, they locked Cursor into an exclusive testing period.
So nobody else can touch them.
Right. While SpaceX is running their internal tests, giants like Microsoft, Google, Anthropic, they're legally barred from acquiring or even investing in Cursor.
That's wild. SpaceX essentially bought a massive $10 billion pause button for the rest of the tech industry.
That's exactly what it is.
Okay, that makes the strategy clear, but we really need to talk about the target itself. Cursor is generating around $2 billion in annualized revenue right now, which is just explosive adoption across the software industry.
It's unheard of for a company this young.
Right, and the CEO, Michael Truhl, is what, 25 years old?
Yeah, 25.
But if you spend any time on the developer forums or Reddit, there's a very vocal contingent claiming this whole valuation is a joke. They call Cursor a VS Code wrapper.
Yeah, the wrapper critique. I've seen that a lot.
Yeah. The argument is that, Microsoft built the underlying text editor, Anthropic or OpenAI built the language models, and Cursor just slapped a pretty chat window on top of it. If that's true, SpaceX just paid $10 billion to test drive a user interface.
Well, the wrapper critique is super common, but it completely misunderstands the actual engineering at play here.
How so?
So a basic wrapper just takes your text prompt, sends it to an AI model, and pastes the answer back. It's blind to everything else you are doing. Cursor operates on a completely different level.
Okay.
Instead of just sending isolated prompts, Cursor indexes the developer's entire local hard drive. It maps out the complex, multi-dimensional relationships between thousands of interacting files in a massive code base.
Oh, I get it. So it's not just looking at the single page of code I have open, it's reading the entire library of books I've written to see how they all connect.
That's a really good way to look at it. If you ask a standard AI to change, say, a user login feature, it might write a pretty good function. But Cursor understands that changing the login feature in your front-end interface requires updating the database schema in a completely different folder,
Right.
and modifying the security protocols in a third file, and updating the API documentation in a fourth. It holds the entire ecosystem in its memory.
So it actually sees the big picture.
Exactly. That deep contextual integration is why developers are adopting it so rapidly. It's not just a chat window, it's an active collaborator that sees the whole board.
But I mean, deep integration doesn't necessarily mean better output, right? If I integrate a flawed tool deeply into my workflow, I just make mistakes faster.
Well, that's a fair concern.
We see these massive valuation numbers, but what does the actual data say about developer output? Like, do we have hard academic evidence that this fundamentally changes how fast humans can write software?
We actually do. And the recent data coming out of university computer science departments is pretty striking. There was this comprehensive meta-analysis of A/B testing from late 2024 through early 2025.
Okay, so it's super recent.
Very recent. And it tracked thousands of developers. One control group used standard coding environments, and the experimental group used deeply integrated tools like Cursor.
And what were the results?
The experimental group demonstrated a tangible 30 to 55% speed increase in completing complex programming tasks.
Wait, really? A 55% speed boost?
Up to 55%, yeah.
If I'm managing a software team, that means a massive infrastructure update that used to take my team a month could potentially be rolled out in under 2 weeks. That's game-changing.
The compounding effect on productivity is massive. And the studies also highlighted that this speed boost is particularly pronounced for junior and mid-level developers.
Because it's helping them learn.
Exactly. The tool acts as a real-time interactive tutor. When a new hire joins a company and faces a legacy code base with, millions of lines of unfamiliar code, the onboarding process usually takes months.
Right, they just have to sit there and read code for weeks.
But with these tools, the time to first productive code commit drops by over 60%. And surprisingly, the data shows an initial reduction in syntax bugs compared to code written completely manually.
Okay, that sounds like an enterprise cheat code, but there has to be a catch. There's always a catch.
Oh, there is.
If junior developers are suddenly coding 50% faster, what happens when they hit a wall that requires actual systemic understanding? Because I know these language models still struggle with reality sometimes.
You've hit on the fundamental limitation right there. The academic research is very clear that these models still hallucinate when pushed into highly specialized, obscure, or deeply complex systems architecture.
By hallucinate, you mean the AI just confidently makes things up.
Yeah, it's a byproduct of how large language models work. They are fundamentally predictive engines.
Right, they just guess the next word.
Exactly. They predict the next most likely token or word based on patterns. They are very linear. But software architecture is spatial and multidimensional.
Okay, that makes sense.
An AI might write a perfectly clean Python script because it knows the syntax perfectly, but it might not understand that running that specific script will, say, exhaust the memory buffer on the custom hardware your company uses.
So it's like a GPS navigation system. The AI knows every single street name perfectly, and it can give me turn-by-turn directions. But it doesn't have the spatial awareness to realize there is a massive river between the two towns. So it confidently routes me right off a cliff where a bridge used to be.
That captures a limitation perfectly. It excels at localized syntax, the micro-level logic. But it lacks the overarching systemic reasoning required for the macro-level architecture.
It can't see the river.
Right. It cannot replace human creativity when designing a completely new system from scratch.
Wait a second. If I give a junior developer a tool that makes them 50% faster, but the tool routinely hallucinates when it comes to complex system architecture, aren't we just giving developers the ability to write catastrophic, bridge-missing bugs 50% faster?
That is the multi-billion-dollar fear across the software industry right now. It's the exact bottleneck preventing AI from completely taking over software engineering.
And let me guess, this deal is about solving that.
Spot on. Overcoming that specific hallucination bottleneck is the core technical thesis behind SpaceX's $60 billion gamble.
But how does SpaceX fix an inherent flaw in how language models think? Like, that's just how the tech is built.
Well, they believe the answer lies in the data. There's a prevailing theory in applied AI research right now that data is greater than compute.
Let's translate that for a second. Compute is the raw processing muscle, like the hardware.
Yes, the servers, the chips.
And SpaceX already has that covered, right? I mean, they have their XAI division, they're running the Grok models, and they have the Colossus supercomputer, which is one of the largest computational arrays ever built.
Exactly. They have more processing power than almost anyone on Earth. But throwing more supercomputers at the hallucination problem yields diminishing returns.
So what's missing?
What Colossus lacks is perfect, specialized training data. Historically, coding AI has been trained by scraping public repositories like GitHub.
Right.
They feed the model millions of lines of finished, polished code.
Which makes sense. You want to show the AI the correct answer.
It makes sense until you realize it's like trying to teach someone advanced calculus by only showing them the final answer key.
Oh, wow.
They see the result, but they never see the work. They don't learn the logic.
They just memorize the output.
Exactly. But our industry analysis shows that Cursor holds something entirely different. They have a proprietary data set of what are called developer traces.
Developer traces. I'm trying to picture what a choice is. Is it just like screen recordings of developers working? Or a log of their chat prompts?
It's much deeper than that. A developer trace is a high-fidelity, keystroke-by-keystroke data record of how a human engineer actually solves a problem in real time.
Wait, really? Every keystroke?
Every single one. It captures the initial flawed code, the backspacing, the debugging process, the pauses to check documentation, and the iterative logic trees the human uses to finally arrive at the correct solution.
So it records the scratching out and the carrying the one.
Exactly. That's exactly it.
Oh, I see. So by training on GitHub, the AI learned what good code looks like. But by training on developer traces, the AI actually learns how to code. It learns the human methodology of problem solving.
That's the breakthrough. SpaceX's goal during this trial period is to feed Cursor's pristine, massive dataset of human developer traces directly into the raw, staggering processing power of the Colossus supercomputer.
To build a better brain.
Yeah, they want to train a new iteration of models that don't just predict the next syntax token, but actually emulate human architectural reasoning.
Okay, so if Colossus is the world's most advanced industrial-grade commercial kitchen, complete with the hottest ovens and the most expensive mixed equipment on Earth, Cursor is walking in with the secret family recipes.
Love that analogy, yes.
They have the step-by-step instructions on how the best Michelin star chefs actually move around a kitchen and build the menu. SpaceX is basically paying $10 billion just to see if Cursor's recipes actually work in their ovens.
And if that recipe yields a model that can architect complex systems without hallucinating routing you off a cliff, then $60 billion is a steal.
A total bargain.
Because if they crack that code, the implications expand far beyond just selling a monthly software subscription to web developers. This completely reshapes the identity of SpaceX at a very critical moment in its corporate history.
You're talking about the IPO.
I am. The financial filings indicate SpaceX is positioning itself for a massive initial public offering in late 2026.
And the numbers being thrown around are huge, right?
The valuations being discussed by Wall Street analysts are staggering. They're ranging from $800 billion on the low end up to a historic $1.75 to $2 trillion.
$2 trillion. For context, only companies like Apple, Microsoft, and NVIDIA play in that sandbox.
It's an exclusive club.
And to the general public, SpaceX is the company that shoots rockets into space and lands them on barges. So how does an AI coding assistant justify pushing them toward a $2 trillion valuation?
Well, you have to look at how this technology serves as a multiplier for everything else they do. Internally, integrating a hallucination-free version of Cursor into XAI and Grok could drastically accelerate SpaceX's own hardcore engineering timelines.
Because software runs the hardware.
Exactly. Software is the nervous system of modern aerospace. Imagine SpaceX engineers using a turbocharged AI to program the orbital mechanics for Mars missions, or to design the complex fluid dynamic software for the next generation of Starship engines.
Oh, wow. If they achieve a 50% speed boost in their own development cycles, they shrink the timeline to Mars by years.
Yes, they become their own most important customer.
But a $2 trillion valuation usually requires dominating a global market, right? Not just making your internal teams faster.
Which brings us to the external strategy. This move fundamentally shifts SpaceX from being an aerospace company to being a comprehensive, vertically integrated tech monolith.
A monolith. How so?
Think about the infrastructure they are currently building. They have the reusable rockets providing cheap access to orbit. They have the Starlink satellite network providing global high-bandwidth data transmission.
Right, Starlink is already huge.
And they are currently planning to deploy orbital data centers to host space-based cloud computing that is immune to terrestrial power grid failures.
Wait, let me connect these dots. They are building the rockets to carry the servers. They are deploying the orbital data centers to host the cloud infrastructure. They manage the Starlink satellites to beam that data anywhere on Earth.
Keep going.
And now, by acquiring Cursor, they effectively own the ultimate AI tool that every developer on Earth will use to write the software that runs on those servers and networks.
Yes. They are building a self-contained, winner-takes-most ecosystem.
That is incredible.
If you control the physical infrastructure, the global connectivity, the raw computing power, and the primary software tool of creation, you've dug an incredibly deep economic moat.
They wouldn't just be participating in the tech industry anymore.
No, they would be providing the entire vertical stack from the vacuum of space all the way down to the keystrokes on a developer's laptop. It's vertical integration on a planetary scale.
That level of consolidation is terrifying, frankly. Yeah. And it explains why regulators are probably losing their minds over this call option structure.
Oh, they definitely are.
By preempting the funding round, SpaceX basically bypassed the immediate FTC and DOJ antitrust blocks that would trigger on a traditional $60 billion buyout.
Yep.
They froze the market without technically buying the company yet.
Regulatory agencies are already viewing this as a massive loophole. The scrutiny on AI consolidation is so intense right now, and using a $10 billion breakup fee to lock out competitors is going to invite years of legal challenges.
I can imagine.
But beyond the legal hurdles, there is a massive human element that could derail this entirely. The culture clash between these two entities is severe.
I mean, I imagine the vibe at a 25-year-old's AI software startup in San Francisco is a little bit different than the culture of hardcore hardware engineers trying to weld rockets together in Texas.
It's an integration nightmare. SpaceX and xAI are notoriously intense, hardware-focused, and driven by tight, unforgiving aerospace deadlines.
Right.
Cursor is an agile software startup built by Gen Z researchers accustomed to rapid iteration and flexible structures. You can buy the intellectual property and the trace data, but if the brilliant young engineers who actually understand how to train these models hate the new corporate culture,
they'll just leave.
They will simply leave.
Yeah.
The $60 billion buys the data, but it doesn't guarantee the talent stays.
And as we look at the labor economics of this, there's an obvious tension here, too. We are talking about tools that make a junior developer 50% faster. In a purely rational corporate spreadsheet, if my team is 50% faster, I don't need to hire as many junior developers next year.
The labor market is actively grappling with this efficiency paradox right now. Will this technology augment human workers, allowing smaller teams to build incredibly complex, ambitious software that was previously impossible? Oh, wow. Or will corporations use it simply to displace the entry-level workforce, hollowing out the training ground for the next generation of senior architects? The data on productivity is clear, but the data on long-term labor impact is still being written.
You know, it's easy to look at a $2 trillion aerospace valuation or orbital data centers and think this is just Silicon Valley billionaires playing chess with each other.
Sure, it can feel very disconnected from daily life.
Exactly. But if Cursor's trace data genuinely solves the hallucination problem, and this becomes the gold standard for software engineering, the code running your car's braking system, the security protocols in your banking app, and the database managing your hospital records are going to be written by this system.
Without a doubt.
The very foundation of our digital infrastructure is undergoing a massive paradigm shift.
We are transitioning from humans writing the instructions to humans guiding the AI that writes the instructions.
Which leaves us with one final, deeply weird thought to mull over. We established that Cursor's real secret sauce is those developer traces, the perfect recorded keystrokes of human engineers struggling, iterating, and solving problems.
Ooh, a scratch pad, yeah.
Right. That human logic is the raw material teaching the AI how to think. But if SpaceX successfully uses those traces to train an AI that codes exactly like the best human engineers, what happens next year?
Well, the system begins generating its own high-fidelity data.
Exactly. What happens when the AI gets so incredibly proficient that it starts tracing its own iterative problem-solving?
That's the turning point.
Right. If the AI is 50% faster and makes fewer architectural mistakes than the humans, then human traces stop being the valuable training data. At what point does human input stop being the secret recipe and start becoming the bottleneck in the very tools designed to help us?
It's a profound question.
If you put down a $10 billion deposit for a test drive, you expect the car to be fast. But what happens when the car learns to build a better engine while you're still behind the wheel?
Yeah.
Keep questioning the rapidly changing world around you, and we'll catch you on the next deep dive.